Okay, so this lesson is going to be on substitution. We touched on it briefly previously, but we're looking at substitution into formulas. So if we get going on this, I've got an equation at the top, a plus b, and if I assign a the value of 3 and b the value of 5, I can rewrite this to be 3 plus 5, which gives an answer of 8. And it's just important that you see that the 5 has gone in the place of the b and the 3 has gone in the place of a. So that's the main key information when we're talking about substitution. We're finding the value for something and substituting it in the place of a pronumeral in a formula. Here's another example. The formula that's been provided is up the top. We have been given the value for b, and we've also been given the total answer, but we can still use substitution to solve this. We'll do it without rearranging, but we don't know the value of a, so I'm going to leave a as it is, but we know b is 4, so I've substituted equals 12, and look, I could rearrange this, but it's not too difficult. Something plus 4 is equal to 12, and I'm hoping that you guys can then see that 8 plus 4 is equal to 12. So I guess they're the two main ways of doing it, where you're often given all of the parts on one side of a equal sign, which was the case in this one here, or you might be given the answer as well as one that's on the other side. So I've got a few examples. Now for all three of these, I'm going to use the same values for x and y, but we're just going to reuse them in each of the three equations. As was demonstrated in the last lesson, I'm going to use brackets when there is a substitution to make it clear. So 3x, 3. Now x in this case is equal to 3, so I'm going to rewrite this with a 3 in the place of the x, plus 2y, y is equal to -2. Okay, so it's important that you see the relationship between this equation here and the substituted values. Okay. So at this point then I can go and evaluate 3 times 3 be equal to 9. Positive 2 multiplied by -2 will actually end up being a -4 or -4. And I've run out of room here, so I'll just put that, which is equal to 5. Okay. We'll do another one here. So here we go. Remember, we're using 3 and -2. I'm going to rewrite this. 5, 3, -2. So x and y are used together in this example. -3, x again, so that's 3, plus 1. So this example's got x in there twice, so it's sort of reused. Now I'm going to do this twice, well I'm going to multiply this out here. So 5 times 3 is 15, multiplied by -2, we get -30. -3 times 3 is 9, plus 1. So -30, take away 9. Now remember that rule, we did this right at the start of the year. In this case, the number is going to be lower than -30. So if -30 degrees and it got 9 degrees cooler, we'd end up with, I'll do this in 2 steps, plus 1, -39, it's getting 1 degree warmer. So there's our final answer. Okay. And then the last example, remember, I'll just write this out here again. X is 3, y is -2. That's right, isn't it? Yep. And I'll substitute again. Okay, 3 times 3 is 9. -2 squared. Remember, our order of operations means that we actually have to do this bit first. -2 times -2 is +4. Now, that's one that your calculator can't always be relied on. So in this case, we'd end up with +13. Now, in life and some practical settings, hopefully you guys remember this formula. Area of rectangle is length times width. Sometimes they say breadth, but in this case, length times width. And again, if I was looking at the area, if I was given 12 and 5, and think about this, if you were sort of paving a backyard area or grass or tiling or painting or anything, some practical application, which equals 60 centimeters squared. Now, to step it up a little bit further, what I've got here is a formula. Look at the blue text, which is the distance traveled by an object in a straight line is given by this formula. Now, assume that we've got something that's moving already. It's moving in a straight line, but it's speeding up. So you need to think about that as a concept. Almost think about if you're sitting in the car with a parent and they overtake somebody, often you need to accelerate to do that. So we can actually measure the distance something travels based on what their starting speed is, what their acceleration is, and how long they're accelerating for. So this is a practical example of how we can use substitution. So I'll highlight. A car starts at 50 meters a second. So it's traveling at 50 meters a second. So I'm going to highlight. And accelerates at 6 meters a second for 7 seconds. How far has the car traveled? Now, what I'm hoping is that you see that there are bits that I've labeled here. So U is the starting speed, A is acceleration, and the time is given as T. Now, the whole lot will give us an answer of X, okay? Now, I'm hoping that the wording in the question will make it a little bit easier to identify which bits go where. Now, a car starts at 50. So that is actually going to become U. I'm going to put a box around this. And accelerates at 6 meters a second, which is going to become A. And 7 seconds, which is this here, is going to become T. So we have got enough information to solve this. So I'm going to rewrite. X, or the distance traveled, is U, 50 meters a second, multiplied by T, plus 1/2, which is part of the formula, 7 times T squared. So, sorry, I mucked that up slightly, but what we're looking at here is we've got a formula up the top, identified each of the bits, and look, I just made a very careless mistake in getting confused about which bits go where, which is quite common, something that I think you guys should be aware of within yourselves as well. So let's just do another check. 50 goes in place of U, okay? T time is 7, so that goes in for the UT. Half A, acceleration is 6, and time is 7 squared. Okay, now remembering our order of operations, I'm going to do a few things here. So 7 times 50 is equal to 350. Okay, plus I'm going to do this bit in 2 stages. because I'm going to turn this 7 squared into 49, which is 7 times 7. Okay. Then equals 350. Now, half times 6 is 3. 3 times 49 is 147. And then I'm just left with this, which means that our car in this situation has travelled 497 metres, which is actually almost half a kilometre. And that'll take, so that's taken the 7 for 7 seconds. The car's travelling pretty fast. Now I'm going to use the same formula for the next one. Whoops, I've gone too far. Now, the slide almost looks the same, but it's actually question B here. So it's the same formula, the top half is exactly the same. But the question in this case is slightly different. If a car travels for 500 metres in 10 seconds with a constant acceleration speed of 7 metres a second, what is the starting speed? Now, this is an example where you're given enough to work this out, but you're actually given the answer. We've actually been given X. So if I mark this here again, we know what X is. So X is there. Ten seconds is going to be time, and acceleration speed is going to be A for our acceleration. So we can then use the same formula, but we're given the answer. So we know it's 500. Have we been given U? No. Now that means that we're actually looking for U. So U multiplied by 10 plus half our acceleration, which is 7, multiplied by t squared. What does this look like if we simplify? U times 10 plus half 7 times 100 500 equals U times 10. So half of 7 is 3.5 times by 100. Okay. So it's at this point that I need to do some rearranging, and we haven't done a whole bunch of practice on this. What I'll do, we haven't done a whole bunch of practice on this year. I'm going to take 350 off both sides, and hopefully some of you guys will remember doing this in the past. So if I take 350 off both sides, I get 150 equals U times 10. And 350 take away 350 is 0. And again, look, we'll do more practice on this, but if I now divide both sides by 10, Mr. Ryan can help you with this if you need some practice. 150 divided by 10 is 15. And these cancel out, which means I get an answer of U equals 15. Now, if I switch back to the question, what was the starting speed? This car was traveling at 15 meters a second. Okay, so that's sort of how we're reading these answers. That's quite a tricky one. So you need a little bit of practice. The first bit here, so on page 58, I want you to practice substitution on all three of these. If you finish that, I think you guys need a bit more practice on word problems, which is then on page 61.